Thank you for coming to another Cleverti talk. Today's talk will cover a brief overview of Coursera introduction course on computer science algorithms, and the speaker is our colleague João Rebelo, a senior Java developer. Please note that we are holding this talk as a normal Teams meeting, and it is being recorded in order to upload it on Cleverti's YouTube channel. So if you didn't subscribe to our channel yet, feel free to do it. There is a podcast with more than 10 episodes and more of these Cleverti talks. You will be able to interact with João, but I will ask you to mute your microphone while João is presenting and unmute it just when you want to ask something. João, I think this one is your fourth talk, but the pleasure we have to hear you remains the same. Thank you, João. The stage is yours.
Hello, everyone. Thank you for attending. First of all, as Mario said, this will be a talk on a course I've taken on computer science algorithms. Thanks to Cleverti, Mario, and Dimitris for letting me do this. And as I've recently finished this course on algorithms, I felt it would be a great thing to show it to everyone. We'll be calling it a personal review of mine, personal opinion of mine, and this is very important to refer. It is only my personal opinion, my personal take on the course I've done. The course itself is prepared by the University of California, San Diego, and is made available on Coursera, covering the basics of computer science algorithms, as previously mentioned. The talk will be about my personal opinion on the course, the first course on algorithms, on computer science algorithms, and the key topics I want to talk about are a brief overview what the course is all about, my personal motivation for why I choose this course, in particular. What I consider that was the more juicy topics that were talked about in the course, and my speech with some final remarks, and there will be a kind of a bonus fact that I've discovered as well in the final remarks section. So the course, talking about the course is part one of a Coursera specialization in the algorithms and data structures, going from being the first part from simple things such as asymptotic notation concepts, greedy algorithms, and some of the basic algorithms that everyone should know in computer science, up to graph algorithms on graphs, strings, ending with a capstone project in the human genome, on the reconstruction of the human genome, which was a project that was finished like somewhere around 20 years ago, which for me it's an amazing thing because I love the healthcare sector and everything related to the human body. So it's just like the cherry on top of the cake. It is prepared by the University of California, San Diego, and it is made available on the Coursera e-learning platform, covering the basics of computer science algorithms, namely asymptotic annotation, or 𝘂𝙧𝙚𝙚𝙾 notation is also another expression that can be used. Greedy, in three main types of algorithms: greedy, divide and conquer, and dynamic programming algorithms. As to my main motivation for taking this course and starting what I would say another journey in my professional growth, was the necessity that I felt to improve the software that I delivered. Namely, by covering some top topics and reviewing some topics that I thought that weren't as clear as could be from what I learned 10 years ago, or almost 10 years ago in college. And besides that, there is also, as always, my own thirst to know more about everything. In the meantime, while in the first few weeks of the course, I had the opportunity to know that there is also another course in Coursera about bioinformatics, which, as I talked a minute ago or so, it's kind of another cake. Instead of a cherry on top of the cake, it's another cake that I wanna try. I wanna try to hit. So moving on to the juice of the course, the algorithms themselves. As I've said, there are 3 types of algorithms that were covered, and I think this was the main focus of the course, teaching me about these 3 types of algorithms, namely greedy algorithms, divide and conquer algorithms, and dynamic programming algorithms. Since they are classified in 3 categories. The concepts behind them are a little bit different, and I'll have the pleasure to explain them as we move forward with some code examples as well. So, in my opinion, and from what I've learned, a greedy algorithm is always an algorithm that makes an optimal local choice, and I'll have the opportunity to explain what that is in a minute with an example, while leaving a sub-problem of the initial problem to be solved. And what this is, moving towards the example, is that, for example, we have the most simple example as possible, and I think that will relate to everyone. We want to exchange a given amount of money, let's say 25 euros, and we have coins of, forget the fact that we are completely out of reality here, because we don't have 10 euro coins, but let's imagine that we have 10 euros, 10 coins of 10, 5 and 1 euros. And we want to exchange 25 euros. A greedy algorithms, and we'll see what this is the local choice is just a local choice. I will explain the global local choice a few minutes in, while talking about dynamic programming algorithms. We'll see why the greedy algorithms always make the local choice. If you look up into this while section of the code here, we'll see that the algorithm itself we won't explore all the possible options to exchange the given amount of money. Let's say again, we want to exchange 25 euros. The algorithm here won't try to exchange those 25 euros with and try out all the possibilities of starting with, okay, let's start by exchanging with a 10 euro coin, with a 5 euro coin and 1 euro coin, and pick the best possible scenario out of these 3 scenarios. It will go through just one scenario. In this case, it will start with exchanging with the 25 euros with a 10 euro coin, leaving us with a smaller problem, a sub-problem of the initial problem, which is exchanging 15 euros with 10 euro, 5 euro or 1 euro coin, and so on and so forth, until it exchanges those 15 euros and there's no money left to return. Moving on to divide and conquer algorithms. The main idea is that they break the problem into a subset of non-overlapping subproblems, and each subproblem must be solved, or should be solved, or can be solved independently. And here I'm going to use the quicksort algorithm. The basis, I won't dive into the partition algorithm and how that is done, because I think it's out of scope. But looking at the quicksort algorithm, what we have here is that we will pick a key. The quicksort algorithm basically sorts a list of elements. It orders a list of elements. Let's say in this case it orders a list of integers, and it will order them from the least valued integer up until the highest valued integer, from left to right. And the idea is that we pick a key, being the key an element in the list where we will use in the partition algorithm. And what that partition algorithm does, it's that it takes that key element and puts all the elements, all the values in the list that are less or equal to that key element to the left of the key element, and all the highest value elements to the right of the key element. If we look at it from a point of view, is that to the left we will have all the elements that are less or equal, and they are unordered. We don't have an order in that left part of the list. And to the right we will have all the elements that are of a higher value than the key, again being unordered. But those two parts that are left, the left part and the right part, are themselves sub-problems to be solved with the partition again, picking up another key and sorting by the same principle, by choosing putting to the left the elements that are less or equal to the key, and to the right the elements that are bigger than the key. And so, as you can see, those problems can be solved independently of one another. You can solve the left first, the right first. You can parallelize both the left part and the right part into, I don't know, different computer systems themselves. And that's the main point of divide and conquer algorithm. And there comes the last class of algorithms that were covered, namely dynamic programming ones. And the main difference, at least from what I saw from a greedy algorithm, is that the dynamic programming algorithm has two main it has two things that identified as a dynamic programming algorithm. It will make the optimal global choice for a given solution, and it guarantees that it will provide us with a solution if we can prove that solution exists, for example, by mathematical induction. Going back to the exchange example again, if we add a condition that we want to provide the exchange for a given amount, but with the least amount of coins, we can easily see that, for example, a greedy algorithm won't work here. The previous greedy algorithm that I showed, won't work. And let's find an example that suits us. So let's say that we have coins 5, 4, and 1, and we want to exchange the value weight. If we apply a greedy algorithm, the previous greedy algorithm I talked about, we will see that that greedy algorithm will find us a solution, but that is non-optimal, meaning it will give us a coin of 5 and 3 coins of 1. And in this case, we can do better. We can exchange 8 euros with 2 4 euro coins. And how does a dynamic programming algorithm do that? Basically, it will try to find the minimum amount of coins to exchange every possible value up until the value we want. Trying to translate this a little bit better, we start, for example, we want to reach we want to exchange 8 euros, we will start by knowing the minimum amount of coins to exchange: 1 euro, 2 euros, 3 euros, 4 euros, 5 euros, 6 euros, 7 euros, until we reach our intended target, which is 8 euros. And through each of through each of these steps, we will find the minimum amount, and in the end, what we will have is the minimum amount, the guaranteed or a guaranteed minimum amount of coins that we need to exchange those 8 euros with 5, 4, and 1 euro coins. So my final remarks about this course: I think it was worth it. For me, it was definitely worth it. It basically surpassed my expectations in the aspects in what I was kind of looking forward to learn from this. For example, it covered a little bit better what asymptotic notation was, with more practical examples on how to, for example, find out what kind of cost does a given algorithm incur in terms of asymptotic notation. It even allowed me to learn new classes of algorithms, namely dynamic programming, which, even though I kind of sometimes did them by I applied them in a day-to-day basis. I didn't know that there was a class of algorithms that were called dynamic programming algorithms. So all in all, I think that it covered, it went into a little bit more depth of what I learned in college, and I think that for me it was very, very worth it. Besides that, as I've previously mentioned, it allowed me to know that there is a bioinformatics specialization. And now the bonus fact is that one of the Bibles used to teach algorithms is going to get a 4th edition, and it will come out on March next year, March 2022. And I think everyone should buy that book, should have that book by their side. Everyone that wants to be a very good software engineer. And that's it on me. Thank you everyone for listening.
João, thank you very much, man. You never disappoint us. I hope you can answer if there are any questions our attendees would like to ask you. Dimitris might have some questions on dynamic programming. Am I right, Dimitris?
Well, I just, yeah, thanks for the talk. Very interesting. I'd like to know what's the next step for you in the sense of study. You know, I mean, after someone becomes more familiar with these things, they can do lots of different steps after. So what's yours? You mentioned bioinformatics. You want to give any more details?
Yeah, so as I've said, this is the first part on a specialization in Coursera that consists of seven courses, if I'm not mistaken. I might be mistaken in the number of courses, but it is there is a 7-part specialization covering like the basics, which was what I've just finished, up until more advanced thing on trying to replicate the project, an international project on building the human genome that was finished a few years ago, I think 20 years ago. So that is going to be I'm going to follow that to the end before moving on into the bioinformatics course, which by the way is Python.
You really need to move to Python. I was about to say, good.
Yeah. I think that the bioinformatics one is all on Python. Is done all on Python.
Great. Anyone else? Any other question?
Are there any more questions?
if there aren't, I'd like to give a challenge to the audience to do at home if they are interested, and get back to us later.
Do it, man.
So, I mean, you all saw this kind of a challenge of making change using coins, and one of the assumptions is that you have as many coins as you want. I mean, maybe some of you are going to be interested to go and see how this type of thing works, and maybe as an exercise, if you really want to understand what's happening, try to figure out how you would do it if you didn't have infinite coins. If you just had some coins in your pocket, for example, and a specific number of each coin, how would you approach it? And if you decide to do that, get back to me whenever you want, and we can discuss your solution.
Thank you, Dimitris. Well, if there are no more questions, let me thank you, all of you, and João especially. As I said before, this talk will be available soon on YouTube, and the best way to be updated is by subscribing our channel. It's easy, isn't it? Seriously, guys, it was a pleasure. Hope we can meet again as soon as possible. Stay safe. See ya.
Thank you, João, once more.
Thank you, everyone.
Thank you.